Okay, good morning all. Are you able to see the screen?
Yes, sir.
Okay. So yesterday we discussed about inverting amplifier. Okay. So what was the gain of the inverting amplifier? What is the formula for gain of the inverting amplifier?
Minus RF by R1.
Minus RF by R1. Okay. So in inverting amplifier, you can see that the output was fed back through a resistor RF to the inverting terminal of the op-amp. Okay, and the non-inverting terminal was grounded. So today we will be discussing about non-inverting amplifier. Okay. So we'll straight away go to the circuit diagram of the non-inverting amplifier. So here also the output will be fed back to the inverting input terminal. Okay, that is what is known as negative feedback. Okay, so I am in feeding back the part of the output to the input side using the resistor. Okay, and then the input is actually connected to the non-inverting input terminal. So you can see that the input is connected to the non-inverting input terminal here. Okay, so straight we will be giving the bias supply VCC and the negative bias supply VEE. Okay. Then this is the input voltage V in, output voltage is here VO, and this resistance, that is the feedback resistance, I am marking it as RF, and this particular resistance I am marking as R1. Okay, so this is the circuit. Now I am going to mark the current flowing through the different resistors as well as terminals of the op-amp. So first I will mark this current flowing through the inverting terminal of the op-amp. I will be marking it as I minus. And this one I will mark as current entering the positive non-inverting terminal. I will mark as I plus. So for an ideal op-amp, what is the value of this I minus and I plus? For an ideal op-amp?
0.
0. Now non-inverting terminal voltage I'm marking as V minus, and non-inverting input terminal voltage I'm marking as V plus. So everything I have marked now. Now what I will do is I will mark the current flowing through RF, that is a feedback resistance. I will mark it as IF. Okay, I am marking it from left to right. Similarly, the current flowing through R1, I am marking as I1, again from left to right. Now we know that the current entering the inverting and non-inverting terminal of the op-amp will be 0. That is what you guys just now told. So I minus is equal to I plus is equal to 0. So for any analysis, we'll be starting with this first. That is the current entering the inverting and non-inverting terminal of an ideal op-amp is 0. Okay. So I minus is equal to I plus is equal to 0. Now looking into the figure, can you tell me what is the voltage at the non-inverting terminal? What is the voltage at the non-inverting terminal?
V plus equal to 0.
V plus is not 0, right? Check. V plus is what here? Non-inverting terminal is connected to what here? See here. This terminal is connected to what? Is it connected to ground? No, right? So what is it connected to?
V in.
V in. Okay, so please note here the non-inverting terminal is connected to V in, which means that V plus should be equal to V in. Is it correct? You understood?
Yes, sir.
Okay. So now according to virtual ground, what concept is there? V minus should be equal to what?
V plus.
V plus. So what should be V minus?
0.
What is V plus here?
V in.
So what is V minus? What should be V minus?
V in.
V in. Understood?
Yes, sir.
Is it clear, everybody? Any doubt? I hope
No,
this
sir.
is clear. Okay. So since V plus is equal to V in, according to virtual ground concept, V plus should be equal to V minus, which means that V minus also should be equal to V in. Okay. Now let us write the equation for current I1. Can you tell me what is the equation for current I1? Equation for current I1?
V minus V naught by R. 1.
I1 means this current, correct? So this potential minus this potential divided by R1. What is this potential?
0.
0. What is the right side potential?
V minus.
V
V
minus.
minus. So it will be 0 minus V minus by R1. Is it clear?
Yes, sir.
So, but what is V minus?
V in.
V in. So what is I1?
Minus V in by R1.
Correct. Minus V in by R1. Is it clear?
Yes, sir.
Okay. Now I'm going to write the equation for IF. So tell me what is the equation for current IF?
V minus of V naught by RF.
V in minus V naught by RF. Or I can write IF is the current flowing through RF, which means this potential minus this potential divided by RF. This potential is V minus, this potential is V naught. So IF is equal to V minus minus VO divided by RF. But V minus is what? V in. So IF will become V in minus VO by RF. Clear?
Yes, sir.
Yes, sir.
Now we are going to apply KCL at the non-inverting inverting terminal of the op amp. So what is the KCL at this point? Inverting terminal. Only this point we can apply KCL here. So what is that?
I1 equal to IF
Hmm.
plus I minus.
I1 equal to IF plus A minus. Now I know what is I1 and what is I minus and what is IF. So I1 is equal to I minus plus IF. I1 is minus V in by R1. What is I minus? What is I
0,
minus? 0.
0.
And what is IF is V in minus VO by
V naught
RF.
RF.
So now from this, I can find an expression for VO. So I am writing this minus V in by R1 equal to V in by RF minus VO by RF. So VO terms I am bringing to one side. So it will become VO by RF is equal to V in by R1 plus V in by RF. So V in is common. I am taking outside from the right side. So it will become VO by RF is equal to V in into 1 by R1 plus 1 by RF. Now I am going to take the LCM. So it will become like this. VO by RF is equal to V in into RF plus R1 divided by R1 RF. Okay. So again, RF gets cancelled. So V output is equal to V in into RF plus R1 by R1. Is it clear? Just LCM and cancelling out the common terms. Any doubt?
No, sir.
Okay. So this is what we got. V output equal to V in into RF plus R1 by R1. So this can be written as 1 plus RF by R1, correct? Because RF by R1 is RF by R1, R1 by R1 is 1. So V output is equal to V in into 1 plus RF by R1. So this is the equation for output voltage of a non-inverting amplifier. Okay, V output is equal to 1 plus RF by R1 into V in. So what is the gain of this amplifier, gain of this non-inverting amplifier? Gain means what? Ratio of output voltage to the input voltage. So what is the gain here?
One plus RF by R1.
Correct. 1 plus RF by R1. Because gain is equal to V output by V in. So from this equation, V in if you bring to this side, you will get V output by V in is equal to 1 plus RF by R1. So gain of a non-inverting amplifier is 1 plus RF by R1. So please remember, output voltage of a non-inverting amplifier is given as 1 plus RF by R1 into V in. Okay, and the gain is 1 plus RF by R1. Okay, so here will there be any phase shift between the input and output? If the input is negative, what will be the output? Will it be positive or negative? If the input is positive, what will be the output? Positive or negative?
Positive.
Positive itself. Okay, which means that there will not be any phase shift between the input and output. If the input is positive, output also will be positive. If the input is negative, output will also be negative. Okay, so there won't be any phase shift between the input and output, which means that phase shift will be 0. Okay, so this is how the input and output will look like. Okay, if you are applying a small input, you will get an amplified output. Okay, you can see here that when the input is positive, output also is positive. Whereas for an inverting amplifier, it was just the opposite. When the input was positive, output was negative. Clear? Any doubt?
No, sir.
No, sir.
Okay. So I'm generalizing it. Okay. So this was the inverting amplifier. Output voltage. What is the expression for output voltage of an inverting amplifier?
V in into minus RF by R1.
Correct. V output is equal to minus RF by R1 into V in. Okay. So gain is, what is the gain? Voltage gain?
Minus RF by R1.
Minus RF by R1. Similarly, this is our non-inverting amplifier. Okay. So gain is, sorry, output voltage is
V in of 1 plus RF by R1.
V output is equal to 1 plus RF by R1 into V in. Okay. So gain will be equal to
1 plus RF by
1
R1.
plus, correct, 1 plus RF by R1. So this you should remember. You should remember the circuit diagram and you should remember the formulas also. Is it clear? Okay, now let us do some problem. Okay, I think this we have done. Okay, this we have done, sorry. Okay, this we have to do. Design a non-inverting amplifier for a gain of 5. Find the output voltage, current through the resistors, the input current and the voltage gain for an input voltage of 0.8 volt. Okay. So the question is to design a non-inverting amplifier for a gain of 5. Okay. So the gain required is 5. Now, what is the formula for gain? What is the formula for gain?
One plus RF by R1.
So 1 plus RF by R1, correct. Gain is equal to 1 plus RF by R1. So 1 plus RF by R1 should be equal to 5 because that is what is given in the question. Which means that what should be the value of RF by R1? What should be the value of RF by R1?
4.
4.
4. So RF by R1 should be equal to 4, which means that RF should be equal to 4 times R1. Now what will I do? I will assume a value of R1. I'm going to take R1 as 10 kilo ohm. Then what should be the value of RF? What should be the value of RF? R1 I have taken as 10 kilo ohm. Then what should be the value of RF?
40 kilo ohms.
Correct. 40 kilo ohms. So RF is equal to 4 times R1. Correct. So 4 into 10 kilo ohm, which is 40 kilo ohms. Is it clear? Understood, right?
Yes, sir.
Okay. So now you can draw the circuit diagram. So this is the circuit diagram, correct? And replace the value of the resistor RF with 40 kilo ohm, and the value of R1 you mark as 10 kilo ohm. So this is the circuit diagram. Now question is the remaining part of the question is find the output voltage when the input is 0.8 volt. So input voltage is 0.8 volt. So what will be the output voltage? What should be the output voltage? Output voltage means what? Gain into input. So what will it be? Anyone?
3.2 volts.
No, what is the gain?
5, sir.
So
5.
What will be the output
4.4.
voltage? What will be the output voltage?
4.8.
4.1.
4.4, sir.
8 into 5, right? 0.8 into 5. How much is that? Output voltage means what? V output is equal to gain into input voltage. That is 5 into 0.8, right? So 4 volt, correct? Yes or no? You understood?
Yes, sir. Yes, sir.
Yes, sir.
Yes, so output voltage is 4 volt. Is it clear?
Yes, sir.
Okay. So now let's find the current. I am marking the current I1. What is the equation for current I1 from this figure? Can you quickly tell without?
Minus V in by R1.
Correct. Minus V in by R1. So minus V in by R1 means minus 0.8 by R1, that is 10 kilo ohm. So it will be minus 80 microamperes. Okay. You can use your calculator and write, no problem. Clear? Similarly, now I will mark IF. What is IF? Formula for IF?
V in minus V naught by RF.
Correct. V in minus VO by RF. So 0.8 minus 4 divided by 40 kilo ohm, which will be minus 80 microampere itself. These two currents will always be same. Why? Because this current is 0. Correct. Current entering the inverting terminal of the op amp should be 0, which means that whatever current is flowing through R1, same should flow through RF. That is why you are getting both same. Is it clear? Done? Shall I proceed?
Yes, sir.
Okay. Okay, now one more question we'll do. A non-inverting amplifier has R1 equal to 10 kilo ohm and RF is equal to 33 kilo ohm. Find and plot the input and output waveforms when the input is 2 sine 2000 pi t and 10 sine 2000 pi t. So yesterday we did the same problem for an inverting amplifier. So today we will do it for a non-inverting amplifier. Okay. So first we will draw the circuit. So this is the circuit, correct? RF is 33 kilo ohm and R1 is 10 kilo ohm. Okay. So can you tell me what will be the gain of this particular RF and R1 is given? RF is 33 kilo ohm, R1 is 10 kilo ohm. So what will be the voltage gain? Can you calculate and tell me? What is the formula for voltage gain? What is the formula for voltage gain?
1 plus RF by R1.
So gain is equal to 1 plus RF by R1. So how much will it be?
1 plus 10 by 33. Sorry, 33
1
by
plus,
10.
so how much is that? 1 plus 33 by 10.
4.3.
4.3, correct. So it will become 1 plus 33 kilo divided by 10 kilo, that is 4.3 is the gain. Is it clear? Okay. Now, we say P in is equal to 2 sine 2000 pi t. So comparing, okay. Comparing it with V in is equal to Vp sine 2 pi ft, what will it be? Vp will be equal to how much? Vp is, what is the peak value of the input? Comparing these two, what you can tell?
2.
Vp is 2. Then what is the frequency?
2 pi f.
So 2 pi f is equal to 2000 pi. So what will be f? 2 pi f is equal to 2000 pi. So f will be equal to 2000 pi divided by 2 pi, which is 1000. Is it clear? So frequency is 1000 hertz. If you know the frequency, you can calculate the time period. So time period is 1 by frequency, which is 1 millisecond. Okay. So what is the output voltage? Output voltage is given as gain into input. Correct. So gain G into V in. What is the value of gain here? What was the value of gain?
4.3.
4.3. So it will become 4.3 into 2 into sine 2000 pi t. So it will become 8.6 sine 2000 pi t. Clear. So the output voltage will be 8.6 sine 2000 pi t. So what is the peak value of the output voltage? What is the peak value of the output voltage? What will be the
8.6.
8.6? Correct. 8.6 is the peak value of the output voltage. So here you can draw the input and output waveform. Okay. So this is the input. Peak value is 2, which means that negative peak will be -2. And time period is 1, which means that one cycle will take 1 millisecond. 2 cycles will take 2 milliseconds. 3 cycles will take 3 milliseconds. Now output is having a peak of 8.6. So this peak value is 8.6 and negative peak is -8.6. Is it clear?
Yes, sir.
Okay. Now second case also we will see. Second case is input voltage is given as 10 sine 2000 pi t. Okay. So 10 sine 2000 pi t means what is the peak value of the input? 10, correct? Frequency again is 1000 only. So output voltage will be gain into V in. Gain is 4.3. So output voltage will be 4.3 into 10 sine 2000 pi t, which is 43 sine 2000 pi t. Will you get 43?
Yes, sir.
43 output voltage will you get? What is the bias supply we have given? Only 15 and minus 15, correct? So will it go above that?
No, sir.
So what will be the output voltage? What will happen to the op amp?
Saturated.
So it will go to positive and negative saturation. Okay. Saturation voltage is again 94% of VCC. VCC we have given as 15 volt. So 94% of 15, which is 14.1 volt. So the input and output waveforms will be like this. Okay. So this is the input waveform. 10 volt is the positive peak. Negative peak is minus 10. But output will not go above 14.1. So at 14.1, it will get saturated and then it will be negative. It cannot go below minus 14.1. So at negative, it will be saturated at minus 14.1. Clear?
Yes, sir.
Okay. Now we will wire this. Okay. So simulation side by side we will do and complete. That is what I have planned. Okay. So I'm just opening this multi-sim. You guys also can do it with me if you are. Okay. So anyway, I will share the link also after completing this. Okay. So let me log in. But I would suggest you guys also to do it with me so that you also will, because one assignment that I will be giving will be based on this multi-sim. So I'm logging in. Okay. Okay. Create circuit. Okay. So now I will take the op amp. Okay. 3-terminal op amp I'm taking. I'm connecting it here. Now I want the inverting terminal to be up. So what I will do is I will little bit let me. Okay. So what I will do is I will flip it first and then rotate so that the inverting terminal will be up. Okay. It will become easy for us to wire. That's why. Okay. Now first let us connect one small DC signal and see. Okay. So I'm connecting it to the non-inverting input terminal. Maybe some 0.8 volt I'll give. Okay. That is what in our question it was. Then we need two resistors. So this is R1. Okay, R1 value was 10 kilo ohm. And RF was 40 kilo ohm, correct. So this I'm changing to 40 kilo ohm. Changing the name to RF so that it will be exactly same as what is done. And V1 also I will change to V in. Okay. Now I'm taking another ground, connecting it here. Now I'll connect it to resistor. Then here. Connected one. Okay. Now click on the op amp and click on configuration pane and change the positive voltage to 15. Okay, that is a bias supply. We are going to give 15 and minus 15. So that is done. Okay. Now I will take one voltage probe. I want to measure what is the output. Voltage VO. I'm changing the name to VO to note that it is output voltage. I'll measure the current also. So I will take a current probe from here. I'll place this here. I'll change the name to I1. Another current probe I will take. I will place it here and change the name to IF. So I'll be able to measure everything. So what is the output that is expected from this particular circuit? What is the output expected? Output voltage expected? What is output voltage expected? What is the gain of this amplifier? What is the gain of this amplifier? What is the formula for gain?
1 plus RF by R1.
So what is the gain here? RF is 40, R1 is 10. So how much will be the gain?
5.
5. So what will be the output voltage? 5 is the gain, means what will be the output voltage? Input I have given
4.
4. So now let us run this and see. You can see that it is output voltage is 3.999, which is 4 volt. Is it clear?
Yes, sir.
Okay. Similarly, so let me save this. I'll change the name to Inverting Amplifier Sample 01. I will save it. Okay. I will give you the link. Okay. Now same thing we will save as non-inverting amplifier example 2, wherein we will give the sine wave. Okay. So I don't want the current probe and all. I just want input and output. Okay. So another voltage probe I will take, connect it here. I'll change the name to Vin. Okay. Then DC supply I will remove and connect one sinusoidal supply, which is the AC voltage. Okay. Now let me connect it here. Okay. So first input that we are giving is 2 sine, which means this. Let me change the name of the Vin I will give. Now let me change the voltage. So 2 volt peak I'm giving. So let us see what is the output voltage that is produced. I'll click on run and I will check the graph. Okay. Let us put this. You can see the okay, but before that, what was the resistor values given? I change that. Okay, so this was 33 kilo. Correct. I did not change that. Okay. in the question. Now let us see. Okay, so this is the input. You can see 2 volt peak input. Peak output is 8.6 something. Our expectation is 8.6. You are getting 8.58. So okay, is it clear? Green is the output and blue is the input. You can see that there is no inversion because whenever the input is positive, output is also positive. Is it clear?
Sir.
Okay. Similarly, I will change it to what was that? An example 2, second input that we gave as a peak voltage of 10. So we can see that it will go to saturation. So 10 volt input I am giving. I am running this. You can see that it will go to saturation. Let me just adjust the axis. Okay. You can see that it has gone to saturation. That is what we got here. Okay. Clear? I hope you got an idea about the concept of saturation. Anyway, we will be seeing this in the lab when you come to college. We will wire the circuit in breadboard and then we will do it. Okay. Is it clear? Yes or no?
Yes, sir.
Okay. Okay, so please try to do the simulations. If you have any doubts, you can ask. Please try to learn that day itself. If you have any doubts, please ask me. Okay. 10 minutes are there. Link for the second example also I'm pasting here, so you can go through it. But please try at least to wire one circuit. Okay, maybe this. Please, 10 minutes is there. So can anyone wire this in multisim and show me the output? This circuit you wire. Maybe I'll make it a little big so that you can see. Okay. So please try to wire this particular circuit. Anyone? Whether you are getting the output that I told. I hope you can see. Okay, so everybody please wire. Some time is there, so let us know. Or you copy from my, you open the link and copy and save as your file, and then you can do that also is fine. Anybody got? No. Sorry. Nobody is trying. Okay, so please